Okay, I'm doing average rate of change of an exponential function. Rate of change is just slope, okay? That's all it is. So if you can do the slope of a line, which is y2 minus y1 over x2 minus x1, that's all you have to worry about. Now, a line, linear equations, they have a constant rate of change. It's always the same because it's a line. That's what all this is. It's just lines being drawn. So that's all this is right here, is just lines. All right. Now, with a quadratic function or an exponential function, you can just find it they usually give you an interval and you find it and do y2 minus y1 over x2 minus x1. Let me just show you. All right. Exponential functions and quadratic functions, same way, y2 minus y1 over x2 minus x1. They give you an interval to do it over. All right, so steps. Let's just go through this. That wasn't really needed. Okay, in 2008, which is right here, about 66 million, we're being asked about this, about 66 million households had both landline phones and cell phones. I don't know too many anymore that do. Use the table to the right to calculate and interpret the rate of change for the interval 2008 to 2011. Again, it is y2 minus y1. You just put 51 minus 66 over 2011 minus 2008. That's the x2 and the x1. That gives us negative 15 over 3, which means that's negative 5. Remember, this is in millions. So about 5 million per household from 2008 to 2011, fewer landlines, and I bet that's 2011. 2021, probably a whole lot more. So 5 million landlines went away, average per year, and we know that it was just average. Okay. Then this one, the table below represents the type of bacteria that doubles every 36 hours. A Petri dish starts out with 12 of these bacteria. It wants you to calculate and interpret the average rate of change over the interval from 2 to 5. So here's 2, here's 5. These are the numbers we're interested in. y2 minus y1, so 121 minus 30 over 5 minus 2. That's 91 over 3, which is about 30.3 bacteria per day, because this is in days. So it's increasing about 30.3 bacteria per day. That is the average rate of change. Again, remember, it's average, it's not constant. Now, if you're looking at a graph, you just look at what they tell you. They tell you over the interval of 1 to 3. So you find 1 on the graph, you find 3 on the graph, and you estimate those values. Okay, my next slide has them estimated. But you want to estimate, this is 1 and some number, this is 3 and some number. Okay, now they gave us, and so when we did it, for 1 we have 550, for 3 we have 1100, so we do 1100 minus 550 over 3 minus 1. And that gives us 550 over 2, so that's about 275 per, per year. Look and see what the table says it is per year. Okay, that's average rate of change. It's y2 minus y1 over x2 minus x1.